Hi, everyone. So my name is Purpose Agile. I'm a PhD student at Purdue, and I'll be talking a bit about a research project that myself and my advisor, James Davis, have been working on. I need to inform you guys that this work is supported by NSF and Cisco. Anyway, so an outline for our talk today, I will be briefly going over the sort of research literature that's out there about ONNX. Then I'll be talking about our study and the method and some of the results. And then finally, there's a brief survey if you guys would like to take it. And it is how you guys can get involved. So quick literature review, just for your reading list. There's been some empirical work on ONNX. This paper, the first one they see, they talk about essentially they convert the model to ONNX, and then they try to see if the properties of the model are maintained after conversion. Second one is some tooling work related to unit testing. And then there's then there are two other works related to sort of applications for different things ONNX has been used for. So our study, so what is our study? Well, we're doing really what is called a failure analysis. We're essentially trying to understand how ONNX fails, specifically how ONNX model converters fail. So in the software development lifecycle, typically you plan a project, you build it, you validate it, and then when everything seems to work, you deploy it, and then when it's operating, things go wrong as they always do. And these bugs, they're undesirable, and it's helpful to understand why they happen. And to do that, academics and industry investigators do these things called failure analyses or failure studies. And the goal of these studies is to essentially understand the causes of these failures and how to prevent them. So typically there's sort of two audiences for this type of work. First is product engineers who work on these things and they want to know how to improve them. And the second audience are users who want to understand the risks of using this sort of software or this sort of product. Sort of in line with that, our work is also just trying to understand failures in ONNX model converters. And our audience, first is the people who develop converters, and second are people who use them. And so I'll be going into some of our findings. So really, our project, it focused on two converters specifically, the TensorFlow to ONNX converter, and then the PyTorch converter. And we tested them in sort of two ways. We first did what is traditional in a software failure analysis, where we looked at historical issues that were reported. We determined which ones are failures, and then we sort of study them in depth. And then the second way is we did some testing of these converters, because it's not just enough to see how things went wrong in the past, but it's good if we could test and try to find issues ourselves. So we asked sort of three questions. What are the characteristics of failures? To what extent do the changes in the ONNX specification relate to converter failures? And then the last question we asked was, how do model converters fail on both real and systematically generated models? When we say characteristics of a failure, what I mean is twofold: the symptom, which is the thing that the user would see, and the cause, which is essentially the impetus of the symptom, the thing that causes the symptom. So skipping that slide. So really, we first study our symptoms. So what are the symptoms that are seen? The two most common symptoms. The first one is sort of, I think it's obvious to everyone in this room. It's like, yeah, converters crash. Everyone knows this. It's not really a big deal. It can be, but that's the most common symptom that you see when you look at the sort of GitHub issues that are out there. The second symptom that is the most common are wrong models, and this is sort of more. This is much more sensitive because you may convert a model thinking it would be one way, but in fact it is another. And that we notice happens around 33% of the time. So historically, out of the issues we studied, we saw 33% of these issues mention this. The second thing, what are the causes of these failures. There are really two main causes that we were able to identify and that we sort of coded. We call them sort of incompatibilities. These are external incompatibilities. All converters, as I'm sure everyone here is familiar, need to sort of stay in line with the ONNX specification. They need to make sure they're supporting the latest operators or operators that people want. And a lot of the times, we notice that many people just, they wanted operators that were not there and they're unable to convert their models. So essentially, in this sense, the converter becomes the bottleneck for them to use ONNX. The second type are type problems, or we call them node type problems. These are particularly related to the conversion of specific nodes. So either a node would not convert correctly, it would, if it does convert, it may not have the same parameterization that it should have. Those are the examples of that. That happened around 23% of the time. The second thing that we tested was, it's not just important for us to sort of know how things went wrong in the past, but it's also important if we understand some, we have some idea of change over time. So the ONNX specification has changed. The question that you should then ask is, do these changes cause things to go wrong, and to what extent they cause things to go wrong? And so we tried to answer that. We did this by essentially mapping every time operators were added, how many were added, and we mapped that with issues that were measured over that period of time. Following that, and we found there's a small, a weak correlation, but there isn't too much. Anyway, I'm running short on time, so I will be brief now. We tested models, synthetic models. So we not just wanted to look at models in the past or failures in the past, but see if we could induce them. So we tested them with both real models from model zoos and synthetic models that we generated. We noticed that synthetic models are really good at causing ONNX converters to behave incorrectly. So implications, what does this mean? Crashes are common, not really a big deal. Wrong models happen, so you should be mindful of that, and there should be more work to try to catch those. And the last thing that we noticed with respect to the synthetic models is the more unusual your model, the more likely it is to create some sort of silent conversion issue. And that's what we noticed with our findings for our testing. And synthetic models would be useful for testing converters. Anyway, here's the survey. Please feel free to take it. Yeah, sorry, I'm running low on time. Yeah, any questions? Yes.
So you crashes, big deal. Like, what does it mean? Does it mean the process generates a core dump? And in my understanding, it's a language process, right?
Yes.
Python, or it just exits ephemera.
So most of the time it was exit with an exception. There are occasional times where you would get a core dump. In this case, we actually lumped those together. The reason we lumped those together is because the latter is not very often, and that's also why I downplay that, as it's usually not really a big deal because it's some sort of expected crash.
Should you file bugs against Python that it crashes?
Well, I assume that most of the crashes are actually coming from the native PyTorch code that's driving the
Yeah.
Piggybacking onto that, have you tried any of the new Dynamo-based technologies inside of PyTorch as well?
No, we have not.
That's the path forward for PyTorch, and I'd be really curious to see, particularly as we add more support for the ONNX exporting, how your research kind of moves forward and applies to the PyTorch 2.0 Dynamo world.
Okay, thank you.
One of the big things is the general torch script coverage should move from about 50% to, we hope, 85 plus, I think is baseline, and then ultimately to 100%. So I would love to actually kind of take that further and kind of reapply what you've done, I guess, more modern PyTorch as well. It's kind of it's still growing and still being built, so the ability to do that right now might be a little premature.
Okay, thank you. Any other questions? Yes.
For a lot of your crashes, were you able to narrow them down to hardware-specific importers, or are you just testing the framework exporters?
So on the systematic testing, that was a lot of the ones that we measured there with this synthetic models were related to ONNX runtime.
Okay.
One of the things that we're trying to figure out is, I think there's another presentation, so yeah. One of the things that we're trying to figure out is whether it's due to the runtime reading a model that is correctly made incorrectly, or whether it's our models are in some way malformed. So we're still trying to parse that.
Thank you so much for your talk. Next, we have Olive.
All right, thanks for your presentation. I think next